Alan said in the introduction, we're talking about mental lexicon through the lifespan, and talking about a fairly novel method that we have for investigating word retrieval. And we'll talk to you first of all about the method, but then we'll also give you some data from our healthy aging cohort and our it's actually a case study of somebody with semantic dementia. This is a project that's funded by the Arts and Humanities Research Council. It also builds on, so the data that we're using actually has emerged from a number of different projects over the years, sponsored by people that you can see on that slide. And we wanted to give a special shout out, first of all, to colleagues Jeremy Tree and Dave Playfoot, who are in the psychology department here at Swansea. They were very involved in one particular section of this research, and Alison Ray at Cardiff University, who's also been involved in previous iterations of this research. So those are big shout outs to them. So yes, as I said, today we're going to look at the big project that we've been funded by the HRC for, aims to determine the potential contribution of word association research. We'll talk about that, what that is in a minute, to our understanding of the mental lexicon. It aims to develop robust methods for word association analysis and also to look at some real world applications. And in doing that, we're going to use data, as I said, collected in previous projects from a whole load of different people. And you can see there, we've got some pretty interesting data sets, some twin data sets, some from blind and sighted people, and so on. The ones clearly that we're going to be focusing on today are these. It's data from young participants, young adults, we've called them there, 16 years old, so on the cusp of adulthood, and also older adults, 65 plus years old, some of them up to 95 years old. That particular data is from the Queensland Institute of Medical Research. And we're also going to look at data from an individual with semantic dementia, which is the data that Dave and Jeremy were very important to us in collecting. So I'm now going to hand over to Theo for the next few slides, and then I'll come back to talk about our findings from our research. So we're going to swap seats. Over to you, Theo.
Hello, everyone. Yes, we're sharing a laptop for the slides, so I'm here now. I'm going to introduce what word association research looks like. I'm going to explain how we collect the data, what the tasks look like, and touch on what analysis we can start doing with it. And then I'm going to hand back over to Tess to explain the findings that she's just mentioned. So, what is word association? I'm sure you can all take a guess at what word association might be, especially if you've ever played some of those sort of word association games. But essentially, the premise is you give a cue word, and then you ask someone to say the first word that comes to mind when they hear that cue. So we can do a little example for the audience today. We've chosen the cue word old. I'm sure some of you have, connotations with this word. It means something to you. So you can think now, what's the first word you think of when you hear the word old? You can write it down, think about it in your head. These are some examples of responses that people might give to the cue old. A common response is young. This is what we call an antonym. It's the opposite of the word old. Or you might say something like wisdom. This is a connotation of the word old. It's something that you think of when you hear the word old. You might say something like fashioned because of the phrase old-fashioned, and this is what we call a collocation. These words often occur together. Or you might say something like ancient. Again, this is a synonym for old. It's a similar word. So these are 4 examples of the types of responses that people give. We're going to talk more later about what it means for us to see these different types of examples. But essentially, these demonstrate the connections in the mind that people would make between the cue and the response. So this is an example of a word association task that we would give to respondents. They can be written or spoken tasks, and essentially you give someone usually 100 cue words, and then they just write down the first word that they think of for all those cues. So what happens with this data? When we've given a lot of respondents, the same set of cue words, what we can do is gather all those responses to the same cue from one set of participants, put them together into what we call a norms list. We've got an example of a norms list for the word old from another research group called Small World of Words, and this is their norms list. So this is a list of words given in response to the cue old. The numbers signify how many people said that word, and it's ordered from the most common response to the least common. With data sets like this, we usually take out the responses where only one person said a response, just to tidy up the data. So can you see your response on the list? Maybe you said one of these words. I'm going to talk now with what you can see in this kind of data. So you can see some words will show the attitudes or opinions that someone might have about the word old, for example. Some words also help us figure out someone's mental lexicon. So, for example, new is a more common word than wrinkly. And so we can assume that you learn new first. So when we're looking at data sets from people who are learning languages, for example, we might expect a more frequent word like new to be learned first. This is also relevant for language attrition, losing words as you get older. And it can help us track the lexicons of people to see when and how they lose these kind of links between more common words that they might have learned earlier in age and less common words that they might have learned later. We can also see how stereotypical someone's responses are. And these are, often the most common responses. The opposite of that is how idiosyncratic someone's responses are. And those are often the ones that not very many people say. So if you said for the cue old, one of the first few words here or the first 5, something like that, we might say that your response is stereotypical. If your response came further down the list, we might say it's idiosyncratic. Past research, which is fairly controversial now, has connected idiosyncrasy of responses to all sorts of things like creativity, personality types, or even psychosis. So it's important to highlight that this data, it's important to see what we do with the data because it has in the past been linked to all sorts of things. So all of these are examples of the different types of connections made between cue and response. And these, we envision them as the retrieval routes in the mind in someone's mental lexicon. So we can see here, we've got, as we said earlier, antonyms, so the opposites, synonyms, collocations, those words that often occur together, and connotations. So here we've got wrinkled or maybe pain, and different people, different groups will have different connotations. So bringing this all together helps us visualize the mental lexicon. And this is a metaphor, this image of the mental lexicon as we kind of see it in the mind, where as a network, where the words might be the nodes and the connections between the words might be the arcs or the lines connecting them. We can think about this metaphor when we think about language attrition in aging. How secure are the tethers between each node? How many links does someone have? And when do these links get lost and how we can prevent that as well. I'm going to hand back over now to Tess to carry on the rest of the presentation. Thank you.
Thanks, Theo. Okay, so I'm back. And yes, as Theo was saying, this network metaphor, and we stress, of course, it is a metaphor. That's not, it might feel like that's what's going on inside your head, but it's obviously not. But the metaphor helps us to think hard about whether when we are experiencing word loss or word finding difficulty, what is actually going on? Is it the route to try to retrieve that word that's problematic, or is it that the word has disappeared or is linked up in a different way, and so on? We're not the first people, of course, to have used word association research to investigate aging or dementia, although there aren't that many, and as you can see, some of them are quite old. There aren't that many studies using word association, but some have found, for example, that in Alzheimer's dementia, the kind of stereotypical connections for words with strong associations get lost or deteriorate. So that an example of that would be old, young. Young was a stereotypical connection. So those, and I think in that piece of research, it's bride, groom, those sort of connections, which are usually quite strong, seem to deteriorate early. There's Gewirth et al. Investigated people with various different kinds of dementia, and they found that as the dementia progressed, there were more of those idiosyncratic responses, responses that nobody else said. But the syntagmatic responses, you'll remember Theo talked about collocations, words that are found together. Those seem to remain intact. And then some work that Jeremy Tree and colleague did, and also some work that I and my colleagues did more recently, showed that older and younger adults differ in the primary response they give to an awful lot of cues. And I can give you some examples of that now. So it's a bit of a busy slide coming up, so prepare yourselves. Okay, there we are. So on this slide, you can see the results of some word association tasks that asked 16-year-olds and over 65-year-olds to respond to actually to 100 different cues. And on this slide, we've got the sample of cues, all of the cues to which the 16-year-olds and the 65-plus-year-olds gave a different primary response. So, and that was, I think there are 52 here. So over half of the cues had a different first response, top of the list response from the two age groups. And some of them are kind of, don't seem to give us much of an idea. I mean, you can see the 16-year-olds for bean and for bread said food. 65 plus were a little bit more specific. I'm not sure how much that tells us. Things like here, if you look at the responses there to extension, so the 16-year-olds said long, perhaps once they go to university age 18 to 20, they might be saying deadline extension. But then with the life experience of the over 65-year-olds, they've got extension and house. And similarly, that there are other things there that we might link, not necessarily to aging, but to experience or to a generation. And of course, it's important not to conflate age and generation when we look at these kinds of things. So this is an initial little experiment that we did, or comparison that we did. And as I said, over 50% of our cue words, the older group had a different primary response from the younger group. In Jeremy's study, that was found as well. Tells us that different generations, possibly different age groups, have different salient associations. And there might be some messages there for intergenerational communication, or just for exploring each other's language, I suppose. But moving on now to the aspects of word association analysis that Theo mentioned, in other words, the type of connection between the cue and response and the actual words that are produced as responses, I'm going to talk a little bit about the effects of cognition and of age on those things. You can see in the background of this slide, we've got word associations are affected by, and there's a whole long list of things there. And part of our big project now is really to pick those apart and to see which ones might affect word associations more than others. On the left-hand side, you can see that there are different properties of the cue word that affect. So there's a lot of white noise going on when you look to try to analyze word association data. But if we focus for a minute then on the type of connection between cue and response, you'll remember that Theo talked about the fact that you find responses that are antonyms, opposites, that are synonyms, mean the same-ish, that collocations go together with the cue word, or maybe connotations. And that kind of categorization is something that in our research we spend a long time doing. In fact, the kinds of categorization frameworks we use are usually more complex than that. So here's one with, I can't remember how many, 15, I think, different kinds of category. So what we do, our method, is to get our set of word association data from somebody who's given a response to each of 100 cues. We go through those 100 cues and we categorize each of them according to this list here. And that then enables us to produce produce an individual word association profile. We call it a profile. So the bars on the chart there for that participant, each bar represents the number of responses that were given in that particular category. So I know you can't see the letters very well there, but from the left-hand bar is the number of synonyms, then the number of approximate synonyms, then CR is the number of collocations. RC is also collocations, but collocations the other way around, and so on. So you can see all of the different types of response there, and we make those into a profile. What we have found is that actually individuals' profiles differ pretty significantly. And the way I came into looking at this research was really by looking at language learners, actually, and the way that their profiles change. And what dominated the research field at that time was this idea of an ideal native speaker language profile that all language learners should aspire to and should be growing towards. But what we found was that actually, as native speakers, first language speakers, profiles differ considerably. So the one participant that you can see there, if I flash up, there we are, that's the bar chart of another participant. And this is a first language English speaker, both first language English speakers, and this is data that they were doing in English. You can see that they differ considerably. So the top participant has got a lot of synonyms and a lot of collocations. Participant at the bottom there, participant number 10, has got an awful lot of those OC, we call those. So those are kind of other connections, other conceptual connections. So for example, like old and wrinkly would be an OC. It's not a synonym, it's not a collocation, and so on. So we found that individual word association profiles differ from each other. And because we are fortunate to have data from bilinguals, specifically Welsh English bilinguals, and we are very fortunate on our current research team to have, you can see his profile there, I think, Steve Morris, who is dealing with our Welsh data for us. We were able to look at these same participants and give them profiles for their Welsh word associations. And the blue lines there are the Welsh associations, and you can see pretty clearly there that the preferred profile of an individual is likely to be the same in both their languages. So that was a pretty interesting finding for us, and we're exploring that a little bit more with some further bilingual data. One thing to say about the profiles, and one thing that we did in a previous study, was give individuals word association tasks every month for a number of months, and we found that their individual profiles were consistent. So, and there are, we measure those for those statisticians amongst you, those you saying, how do you know, and is it significant? We measure the profiles using Euclidean proximity measures. And yes, there is a statistically significant difference between one individual's profile 1, profile test time 2, and everybody else's. So that's a pretty significant finding, we thought. Anyway, what has all this got now to do with aging and with dementia? Well, we're talking about connectivity in the mental lexicon. So far, we've got to a point where we think participants seem to have preferred response profiles that are consistent, large between subject differences, and L1 and L2 response profiles are the same. So let's move on then to ask the question about age-related changes. So this is healthy aging is the context here. Age-related changes in lexical retrieval behavior. Are they a result of cognitive decline or of accumulated learning? And I'm sure that those of you who sign up to CADA webinars are people who have spent a long time pondering and investigating this question, and you probably got some fairly strong thoughts on it yourselves. A lot of you will know that the case for cognitive decline, certainly in terms of lexical retrieval, is that older participants seem to be slower and less accurate in their responses to orthographic phonological tasks and picture naming, and that older participants seem to demonstrate more delay or even to temporarily lose the ability to retrieve the words that they're looking for. And there's a lot of research, for example, the research there that supports those ideas. However, some of you might be familiar with a fairly iconoclastic paper that came out in 2014 by Michael Ramscar and colleagues. And the title of that paper says it all, really, The Myth of Cognitive Decline. So what Ramscar and colleagues set out to do was investigate this myth of cognitive decline by using computer simulations of language acquisition over a lifespan, and then looking at what that tells us about access to words and about the size of the lexicon as well. I recommend you read this paper. For those of you who don't know about it, there were all sorts of, that I heard programs on the radio talking about it. I think there was an article in National Geographic about it. So it shook things up a little bit. And I'm going to read you one. I love this quote from the Ramscar paper. I hope you do as well. They say, the literature of the psychological and brain sciences portrays adulthood as a protracted episode in mental decline, in which memories dim, thoughts slow, and problem-solving abilities diminish, and where researchers seem to compete to set the advent of cognitive decrepitude at an ever younger age. Thus, although studies indicate that older adults are, on average, happier than younger adults, in the light of the foregoing, even this small crumb of comfort might be seen as further evidence of their declining mental prowess. So this is Ramscar's kind of opening parry at challenging this idea of cognitive decline. By challenging the assumptions made about cognitive decline, and after their simulation of lifelong exposure to language, Ramscar and colleagues claimed that age-related changes in information processing are a product of accumulated learning, not from the attrition of cognitive ability. They claim that age-related changes are a natural consequence of knowledge acquisition and are not due to cognitive decline, and that reaction time, and they do point out that reaction time is used an awful lot in claiming that there is cognitive decline, but they say reaction time is not a straightforward indicator of cognitive decline, cognitive function, but is the cost of the increased quantity and complexity of information people hold as they get older. So we'll be interested in the comments to know what you think about Ramscar's claims. But what we wanted to do, having read this paper, was to look at our word association data to see if that would support or disagree with the claims that Ramscar is making there, or if really we could get anything of value out of the word association data to help to progress this conversation. So we investigated the myth of cognitive decline using word association data. We were fortunate, as I said earlier, to have data from some young adults and some older adults. And we were also fortunate that the older adults had been tested more than once, usually with about a 4-year gap in between their test times. And we extracted from the data 43 of them for whom we had that data 4 years apart. So in investigating this myth and in talking about lexical retrieval, I'm going to use another metaphor, and I absolutely owe this to Jeremy Tree. This is a metaphor that Jeremy Tree used when he was giving a talk several years ago, and it struck a chord with me. So I've stolen it from you, Jeremy, but I've put your picture underneath it. And Jeremy uses the metaphor of, and I don't know if he knows the word for this machine, but I'm sure you'll be familiar with it. You see them in arcades, don't you, and fairgrounds, where you have to kind of manipulate that grabber to get hold of some of the little toys at the bottom. So in our metaphor, all the little colored things at the bottom are the words that you're holding here, and the grabber is your retrieval route when you're trying to get hold of the word that you need. So for us to investigate it using word association data, we thought we could look at 3 different measures. So we asked, are there age-related differences in the frequency of words produced in response to word association cues? And as Theo briefly mentioned earlier, word frequency is quite a useful measure, because if people are producing a lot of very infrequent words, that can be a sign of a large lexicon. We also wanted to look for age-related differences in the diversity of words produced in response to word association cues. So do you find that the same words are repeated or not? So those would be represented, that's talking about the kind of word store. But we also wanted to investigate the type of link between the word association cue and the response, and the type of links we've talked about might be semantic or collocational, or the words might look the same or something. So that's really the type of link, is looking at the grabber. So I can start to tell you now what we found. So looking first of all at the frequency of the words produced. The frequency paradigm, as it's often called in applied linguistics, works on the assumption that in language acquisition, we learn the most frequent words first. So there's an inferential assumption then that the more frequent the word, the more likely it will be known. And therefore, looking at frequency can sometimes be used as a proxy for vocabulary size. And what did we find? Well, we found, there's some statistics there, that comparing in the middle there, the sort of creamy coloured cells in the table, compare the younger adults and the older adults, and you can see there the average proportion of infrequent words. Infrequent we've taken as not within the first 5,000 most frequent words of English, and we can talk about that more in the questions if people want, but that's our measure. Older adults, as you can see, produced significantly more infrequent words than younger adults. Okay. So what about our older adults that were tested 4 years apart from each other? Well, there was no significant difference between the number of infrequent words they produced at time 1 and time 2. No difference. So no more growth, but also notably no decline. So those were our findings with frequency. Then you remember we were going to look at the diversity of words, and for this we used something called a type token ratio. The types are the number of different words somebody produces. The tokens are the actual word count that they produce. So typically in the sentence, the cat sat on the mat, we've got 6 tokens, but only 5 types because the is repeated. So type token ratio, that can be used as a proxy for the diversity of somebody's vocabulary. And looking at our data, we found that again, the older adults had a higher type token ratio than the younger adults. It looks really small there, doesn't it? 0.88 to 0.9, but there was a significant difference. The older adults, so similar at time 1 and time 2, and in fact, there was no significant difference there. So I'm going to tell you one more measure we took between these age groups with their word association data, and then we'll kind of summarize what that means and what it means in relation to the Ranscar study. So the third thing we looked at, you'll remember, is the type of the link between the cue and the response. And you'll recognize there, are they synonyms? Are they lexical sets? Are they collocations? The same kinds of links, like those ones that we've talked about before already in the webinar. So our question was, are there age-related differences in the type of link between a word association cue and a response? And you can see a set of data there for some of the categories we looked at. You can see that some of the means look quite different, like for synonyms, for example. And we statistically compared these 2 data sets, and we did in fact find that there was a difference in 5 of the different categories. So the older adults produced more synonyms than the younger adults. The younger adults produced more other conceptual. You remember those, they were those kind of vaguer responses, things like immigration, politics, old, decrepit. Those are those kind of other conceptual responses. The younger group produced more of those. They also produced more form-based, what we call form-based responses. So producing a word that kind of looks like the cue. It might be old and cold or something like that. Or where you've changed the affix, old and older, for example. So the younger group produced more of those as well. So what have we got? Oh, sorry, the comparison between the older adults in test time 1 and 2, no significant difference in any of those measures. So in answer to our question, are there age-related differences in the type of link between word association, cue, and response? Well, yes, it seems that there are. We can interpret our findings as saying that older adults produce more infrequent items than younger adults. Older adults' response data is more diverse than that of younger adults. And this could be interpreted as saying that they have a larger lexical store, which actually is tentative support for that Ramscar study. The older adults also produced more synonymous links than the younger adults, and fewer loose conceptual links or form-based links than the younger adults. So that might indicate a different kind of search mechanism between the two groups, which again is tentative support for Ramscar et al. So the other thing, of course, of note is that we found no significant differences in the frequency or diversity or type of link profiles of the older adults at test time times 4 years apart, which might be taken to support this idea that there is no sharp decline in these features beyond 70, which was one of the claims from the previous literature that Ramscar et al. Set out to challenge. So it seems then from these findings that in lexical decision tasks, we know that in lexical decision tasks and other psychometric tests, older people are slower than younger people. So why is that? Well, the initial explanation of the previous research seemed to be that the brain was slowing down. That's cognitive decline is part of aging. But Ramscar's research and actually our analyses have seemed to indicate that that might not be the case and come up with another explanation, which is that older people have more experience, which increases the quantity and the density of their knowledge. And perhaps recognition speed depends on how many words you know. Older people know more words, so it takes longer to search through them. In other words, slower responses in older age aren't a sign of cognitive decline, but of a fuller brain, to put it in very simplistic terms. So possibly then, age-related changes in lexical retrieval result from accumulated learning, rather than from the attrition of cognitive ability. So we said that we would talk not only about comparing the word associations of younger and older adults, but also about data from our longitudinal study of word associations of someone with semantic dementia. We are interested in exploring not whether the patterns are the same, but exploring whether there are patterns to be seen in the word associations of people with Alzheimer's type dementia, which is more common, but we haven't got the data to be able to do this. And in a way, this experiment with the data from somebody with semantic dementia kind of is a little bit of a proof of concept, perhaps, that these methods might be applicable. This is where I have to give a big shout out to Jeremy and Dave, who did collect the data and have been working on it with me. Semantic dementia, I'm sure a lot of you know, is a frontotemporal dementia which acutely affects language performance, especially, and this is why it's of interest to us, in lexical retrieval and semantic organization. So word association data, responses to 100 cues, were collected from a person living with semantic dementia 6 monthly over a 2-year period. So we've got 4 test times, which you can see there. So this is an excerpt from the data, the first part of the data. You can see the cue words on the left there, and you can see the 4 different test times there. And if we just kind of eyeball that data for a minute, there's one obvious change as time progresses, which is that the last test time, the one on the right, has got more gaps, hasn't it? There are more things missing there. There are more instances of cues not being responded to, person not being able to retrieve a response to the cue. But there are quite a lot of other things in this data that we're interested in looking at as well. If you notice anything yourself, let me highlight a few of them. So you've got quite a lot of repetition, especially as time progresses, of some words like get and got, and do and don't seem to appear more and more. There are some words that that attract the same response in a reasonably stable way. Interesting one there with foster and cold. Well, that doesn't necessarily seem to make sense unless you think, well, foster sounds a little bit like frost. And certainly we do in word association research, we see these kind of chained responses from time to time. But cold is a very stable response in this data set. The words on the right-hand side there in that last test time, there's a fair bit of repetition there and words that it's difficult to see how they relate to the cue, but some of those words are fairly complex words, operation and so on. And if you look especially at the words at the bottom there, the responses to ladder, walk, where, no, step. Well, step is still a pretty sensible, a pretty rational response to ladder, an informed response to ladder, I think. So there's a bit of a mixture of stuff, and there's a lot that we're looking at in this data. But let me just, I just want to be able to tell you the results of the same analyses as we ran on the aging data for this data. So you'll remember that when we were looking at the aging data, we tracked cognitive decline, looked for cognitive decline by looking at frequency, diversity, and the types of link produced. So let's see what those produce for this one person's word association profiles in semantic dementia. So looking at word frequency, well, you can see that at time 1, test time 1, there were 15 infrequent words. 15 out of 100 of the responses were infrequent words. Again, those are words that are outside the first 5,000 most frequent words of English. But there's a pretty noticeable decline in that at test time 2. And indeed, at test time 2 and 3, only 6 infrequent types were produced, and at test time 4, only 5. So at this stage with this data, we're kind of looking at things that might be worth investigating further. We think that might be worth investigating further. And you'll remember that frequency is used in a lot of research as a proxy for vocabulary size. The next thing we looked at was diversity. So we can do the same as with the old and younger adults data with this. And there's not such a marked difference, but we do again see that the count, the TTR count at time 1 and 2 is higher than at times 3 and 4. And the other things that investigating the output of somebody with semantic dementia in this kind of way, the other thing that might help us to understand is the non-linear progression of the condition, I suppose, or at least of the symptoms of the condition. So we don't know at which of these points, which aspects of the lexicon are being weakened or impacted. And then looking at the types of link between the words, well, here we've just selected for you the types of link, the profile at test time 1, that's the blue bars, and at test time 4, which is the purple bars. And the really striking thing there, isn't it, is that by test time 4, there were a lot of those responses on the right, which are erratic responses. In other words, ones that we can't devise what the link was with the cue word. So a lot more erratic responses. and a real decline in the left-hand side of that chart, which is synonyms. So many fewer synonyms. So a decrease then in synonym responses, and an increase, also slight increase in those other conceptual, those looser linked responses. So what does that tell us then, or what might that tell us about lexical retrieval in semantic dementia? Well, it seems that some word meanings seem more well preserved. We looked at the example of ladder. We see that word loss comes and goes. So there was, I think, I'll go back later to the instance of greed, but sometimes a word can appear and disappear for a couple of times, then appear again. And some word meanings seem to be lost sooner than others. I will go quickly back to that data set. You can see at the top there, the example of Abby, we've got name and then get, and then again, and then nothing at all there. And for greed, that was the other example I gave you. Greed, colour, bad, bad, but then eat again at test time 4, where the meaning seems to have come back. Our next steps with this data, and probably what you're thinking to yourself is, well, how do we know that that's an unusual behavior? Because what else will we compare it with? Well, we're going to compare this semantic dementia data with some with a control group, basically, to see how important or how significant those differences might be. But in the meantime, we are minded to conclude that there are implications for diagnosis and tracking of semantic dementia that make it worthwhile continuing with this kind of investigation. So I'm going to stop in a second and give people the chance to ask questions. But just to go back to our metaphor, the metaphor that Theo presented earlier of the network, I hope that what we've explained in the last 45 minutes, from that, you can see that what we're interested in is what is deteriorating, what is likely to deteriorate or to change or to strengthen through the lifespan or as a result of particular conditions in relation to the way words are tethered. Theo used the word tethered earlier on. I like that, the way they're tethered to the network, the strength of the connections that they have, and whether some words that seem to be lost might just be hanging on through a certain retrieval route. And that makes us think about maybe the kinds of strategies that might be used to help people who feel that they're losing their words to hang on to them, to retrieve them more ably. We can't go without saying a big diolch yn fawr, a big thank you to the people who funded various stages of this research and this data collection, and to our many colleagues who've contributed along the way, some of whom we've talked about there. And on our final slide, Theo and I have put our email addresses and our Twitter X handles in case anybody wanted to get in touch or to learn more about the project. I should also say that as part of our big project, we're creating a website called the Mental Lexicon, where we will be putting all of the data that we're generating or that we're analysing in this project for other researchers to be able to use. We feel very strongly that this data has potential, and we would want many people other than us to be using it. So there we are. Thank you very much for your time and your attention. It's been a pleasure to share this with you. I'll stop sharing now.
Well, that was superb. Thanks ever so much, Tess and Theo. That was brilliant. So I'll pass over to Theo now, as I think there are some questions and statements in the chat to kind of round up, if that's okay. So Theo, if you want to take it from there.
Yeah, so Tess, there has been a question from Annabelle, talking about the reaction time specifically. So Annabelle says that if you put a person with all that knowledge into the test system where speed is the measuring point, and the older person knows they'll be judged negatively if they don't conform with accepted measurements, will performance be compromised? Will measuring reaction time impact on the validity and reliability of the data gathered?
Okay. Good question, Annabelle. And we had to think very carefully about whether to include reaction time in the project that we're doing now, and we're not. But there are some really interesting findings about that. I think if I've understood your question right, you're kind of talking about the pressure or the stress, that somebody might feel if they're under pressure if they know that they're being measured. And yes, I agree, that's going to be a factor, and you might end up just not getting responses. There's some interesting things about reaction time, though, or at least about the first responses. So there's been some work by a paper by Santos and Bayan and colleagues. I think there's an overlap actually with the Ramscar research group, and they looked at the kind of the whether the first responses that people give. In our data, as Theo said earlier, we're asking for one response to each word, but some research asks for people to give several responses. And when Santos and colleagues looked at the responses that were given, it seemed to be the case that the first response, the fastest response, was what they call a lexical response, but they usually mean something like a collocation, the sort of word that appears straight, that comes to mind immediately, sometimes without you even thinking about the concept. And that later responses were more kind of conceptually driven. So I suppose it's possible that even if you're not actually saying to somebody, right, you're timed here, if you're collecting several responses from them, you can still test that kind of thing. But this idea of paying attention to the pressures that are on the person being tested is really, really important. But the data that we've got, as I said before, is from the Queensland Institute of Medical Research, and all of those older and younger subjects that we used for the analysis we've presented to you today were in fact one of a pair of twins. So all of that data is from twins. And I was very lucky to be able to go into QIMR and see the data being collected. And some of you might know about the Australian twin studies. These people were coming in for a whole morning's battery of different tests, and one of the tests was the word association cue. And there was a lot of work that had gone around making those participants feel valued. And I know that's very central to what CADA does and believes in as well. But I think I'm going beyond the remit of the question there.
Thank you. Rebecca is wondering if any participants were bilingual or what you might expect to see in these adults. I know there's some research suggesting that bilingualism protects against supposed age-related cognitive decline. However, bilinguals would typically have more words in their brain. Would that contradict expectations?
Well, yeah, thanks, Rebecca. The Australia data, so the data that we're looking at, there were very, very, very few bilinguals in that data. But as part of our big project that we're doing, we're technically calling it the big project, we've got some bilingual data. I did refer to it very briefly, the Welsh and English data. And yeah, I mean, that's a test of the hypothesis of Ramscar, isn't it? Whether as bilinguals, you kind of slow down, but you get more information, you retain more information. And that's something that's empirically testable. And I think it would be a really interesting thing to look at. So at the moment, kind of deliberately, we've got data from people who are older but not bilingual, data from people who are bilingual but within a kind of a middle age set. Part of the reason for that is because we're trying to tease apart some of the white noise you get from all of the things that affect word associations. But I think that's a really valid question. If we're just saying you've got lots more words, therefore it takes longer to get them out, you know, then bilinguals is an obvious place to look for an extension of that. So thank you. Good question.
There's no more specific questions in the chat, but there are a few people talking about their own responses or connotations with some of the Q data given. For example, Annabelle says, my response to Abby, it couldn't be a name because it didn't have a capital letter.
Yeah.
And Gil's saying about the Fosters and the cold. And you know what?
I'd never thought of that about Fosters and cold. It's just laughing because I'd read it there now. Yeah.
So I don't know if you have any thoughts on the sort of bias that we might bring in as researchers.
Oh, it's massive. And I mean, trying to categorize cue and response links is really, really challenging. And we will sometimes get it wrong. So ways in which I've addressed that in past research, I did one research study where after these actually not poor participants, we're lucky because people generally quite like doing word association responses. So it's not considered too onerous. But after they'd done that, I then interviewed them to say, why did you give that response? Why did you give that response? So that gives us some information. Sometimes people just said, oh, I don't know, word just popped into my head. In other instances, what we've done is, well, we almost always do some kind of inter-rater reliability. So several of us will rate certain sets of words and then Typically, there's initial agreement on about 80% of the words. And then usually, if we've rated them separately, when we sit down and discuss it, we'll say, oh yeah, like I just did then, oh yeah, a cold Foster's. Yeah, I hadn't thought of that. And then we agree on pretty much getting on for all of the words. In cases where we just can't agree on a few words, we ask more raters and kind of take the mean, but we're never going to get it completely right. It's really difficult. Especially it's difficult when you're looking at people from a different generation, different culture. It might be a generational culture, or as I say, a lot of this data came from Australia, and there were references to Australian culture and TV and so on that we just didn't know. You can get a bit of information through Googling it. But I think it's really important to acknowledge that what we're actually trying to do is figure out what somebody was thinking when they wrote that response, and we might just not be able to get there. I mean, we talked a bit about intercultural communication. We've presented this data to various groups in the community, and they have tended to be quite older groups like University of Third Age, Women's Institute and so on, and they were very, very interested in exploring their own and each other's associations from a point of view really of kind of generational retrieval, I suppose, and of generational comparison and so on. So that's not the prime thing that we're doing with this project, but I would say that there might be some communicative lessons or at least activities that might be interesting to explore too.
Annabelle's now said that often knowing the person can help people to understand the context in which a response is given, which makes the choices seem more sensible. How does that influence the theory?
Yeah, you're absolutely right. And I think it's interesting to see in the twin data, we didn't present anything from actual pairs of twins today, but there are similarities that they clearly get. So they've both said the same response for a reason, but we don't know. One of the reasons that we tend to look more at the links between the words rather than the actual words themselves is exactly that. We don't necessarily know the context, but we can say, yeah, we know those two words are a collocation. We know that those two words are synonyms. It's kind of easier for us to categorize the data without having to know why the person said exactly that synonym or exactly that collocation.
I think that is all the questions. So I'm going to hand back over to Owen.
Thanks.
Oh, that's fantastic. That's fantastic. Thanks ever so much, everybody. It's been a really interesting presentation. Honestly, thanks to everybody for your participation, for your interest, and for all your insightful questions and thoughts. You've obviously been thinking a lot in the background about the presentation itself. It's been lovely to see so many people attending. And as a Welsh speaker as well, I'm quite interested in the results on the Welsh language. And just to mention, we have a webinar on dementia and the Welsh language on our Cadr website. That's Cadr, CADR.CYMRU, or Cadr Cymru. So finally, thanks very much to our presenters, Tess and Theo. It's been really, really interesting. And also thanks to the Cadr team. That's Kim Meffam, Alex James, and Rhian Williams, for all of the background work in setting up the webinar as well. Now, unfortunately, as I mentioned earlier, it's the last in the current series, or in fact, the forever series of Cadr's webinars. But we really hope you can make our Cadr conference in Cardiff on the 14th of November. So thanks very much, everybody, again. Diolch yn fawr iawn, a pob hwyl. God, God, you can be here. Nice to see you. Owen.
Yeah.
Thank you.